So hello everyone, welcome to our next topic on naive-based classifications. So naive-based is a powerful and versatile machine learning algorithm used for classification tasks. It leverages Bayes' theorem to make predictions based on the probability of event occurring. In this presentation, we will dive into the fundamentals of naive-based, exploring its underlying assumptions and demonstrate its practical application using real-world examples and code snippets in R and Python. Introduction of naive Bayes. What is naive Bayes? Naive Bayes is a supervised learning algorithm used for classification tasks. It assumes that the presence of one feature in a class is unrelated to the presence of any other feature, hence the naive part of the name. When to use naive Bayes? Naive Bayes is well suited for the problems with multiple input features such as text classification, spam detection, and sentiment analysis. It also highly scalable and can handle large database efficiently. Assumptions of naive Bayes. First is independence, second is linearity, third is normality. Naive Bayes assumes that the input features follow a normal Gaussian distribution. Bayes theorem PA by B, PB by A, and PB. Bayes theorem is the foundation of naive Bayes algorithm. It describes the probability of an event occurring given that the probability of another event B occurring. The theorem relates the conditional and marginal probability of the two events. Prior probability. What is prior probability? So, prior probability is the likelihood of an event occurring before any new evidence is takes into an account. Why it is important? Prior probability is a crucial component of Bayes' theorem as it is used to update the probability of an event occurring based on the new evidence or information. How to estimate prior probability? Prior probability can be estimated from historical data, expert and knowledge or assumption based on the problem domain. Likelihood. First is probability of observing data, second is conditional probability, third is maximum likelihood. Posterior probability. It shows the bar chart of prior probability, likelihood, and posterior probability. The posterior probability is updated probability of event occurring after consideration new evidence or information. It combines the prior probability and likelihood to provide a more accurate and estimate of the problem of an event. Naive Bayes in R. In R, we can use the naive Bayes function from the E1071 package to implement the naive Bayes classifier. This function takes in the training, target variable, and the other parameters to build the model and make prediction. In Python, we can use Gaussian NB class from the scalar naive Bayes module to implement. Here is the code snippet for application of naive Bayes using R and Python. First is using Python. Here is the code snippet. You can see that we have imported various libraries, load the data, split the data into training tests, initialize the naive Bayes classifiers, train the model, and make prediction. After that, evaluate the model. Its output is accuracy, typically around 95% for Iris dataset, and classification records provide precision, recall, and F1 score for each class. Using R E1071 package, load the necessary libraries like library E1071 and library caret. Load the Iris dataset, split the data into training set and sets, train a naive Bayes model, make predictions over database, evaluate the model. Output of is confusion matrix. Display actual versus predicted classification. Accuracy typically around 95% for the Iris database. Now here is a small comparison between Python and R on the basis of ease of use, performance, and visualization. By ease of use, Python is user friendly, built-in metrics, but in R is simple but may require more packages. Python is fast and efficient in terms of performance, but R language is also equally efficient. Python requires libraries like matplotlib and R uses ggplot2 for plots. Key insight from naive Bayes. First is assumption. Assumes features are independent through often violated in practice. Strengths, weaknesses.